It is time to let Bob do a little thinking for himself. We'll add a mini RAG system that incorporates a small in-browser LLM and some few-shot learning to round out the depth of his responses. So far, Bob responds using an FAQ. But what if we wanted him to learn from a longer document, like a text file? In addition to an FAQ, we can load text information to use as Bob's knowledge base. This can be specific to Bob, or it can be general knowledge such as a document on JavaScript or other technologies that Bob uses. When the file is loaded, it is embedded the same way as the questions in the FAQ. Except when using the text file, we embed a paragraph at a time. We use paragraphs because small sentences can result in higher similarities, but lose some of the overall context. Or other sentences may lose some context due to pronoun use or other assumptions based on the context in the previous sentence. Overall, it's the same core logic as the FAQ. We embed the paragraphs, compare the query to the embeddings, and return the best matches based on cosine similarity. You can change the text files used by first selecting the book icon just below Bob's avatar. In the pop-up screen, you can remove any or all text files and add new ones depending on the knowledge you want Bob to have. When we ask Bob, "How were you made?" he first finds the answer from the FAQ and responds accordingly. When we ask a question that doesn't have a good FAQ match, Bob uses his text file knowledge to look for a match. Here we lower the threshold from 0.9 used by the FAQ to 0.8 so that we don't restrict the match too much. While this type of retrieval system can work well in many instances, it does have some drawbacks when used for a character like Bob. For example, Bob is now responding in the third person, and the response itself is not the best. The phrase "technologies used to create him" is likely driving the match at 0.837, which is above the 0.8 threshold and higher than other entries. Bob actually returns up to 5 responses that are also above the 0.8 threshold. In this case, the second most similar entry would be the best answer to the question. You could introduce an option for the user to toggle through the responses and select the best one, which would be appropriate in many cases. However, that is not how we want Bob to work. Introducing a small LLM allows for first-person, personality-aware responses. To use an LLM, select the brain icon just below Bob's avatar. In the pop-up window, turn on the toggle for using an LLM to give Bob extra brain power. Depending on whether the system detects the availability of web GPU or not, the choice of model will vary. Smaller models are available for CPU-only computers. We'll select a moderate size model for this example. Now that we have the LLM running, we'll ask the same question so that we can easily compare the responses. As you can see with the LLM, the response is first person and answers the question asked. The full LLM prompt consists of 3 key pieces: the system prompt, few-shot learning examples, and the user's query. The system prompt includes the role that you want the LLM to play, in this case, a helpful avatar named Bob, and it contains the context retrieved from the text file. The context is the text most similar to the user query that the LLM can draw upon for constructing an appropriate answer. RAG stands for Retrieval Augmented Generation. Generation is what the LLM does. Retrieval augmented is simply the added context, since it is retrieved from the text file and used to augment the LLM text generation. Here we are referring to it as a mini RAG, since full RAG systems tend to be more complex than what we are doing for Bob. Few-shot learning is simply some examples of how the LLM should respond. They are user-assistant paired responses. In the case of Bob, we are using the 10 most similar FAQ question and answer pairs to serve this purpose. Experimentation was done using just a few examples, 5 to 7 examples and 10 examples and more, to determine what worked best for the smaller LLMs being used. The best results were with 10. With fewer examples, the model tends to not model the response styles as well, while using more than 10 didn't improve performance. Because the FAQ can contain stylized responses, the goal here is to pick up that style and have the model mimic it in the actual user query response. Within the library, a helper function is used to build the full LLM prompt. The resulting prompt is a JSON-formatted structure. You can pause here to take a look at the commented code to get a better sense of what it looks like in execution. The functions for loading the LLM models and text generation are handled in a web worker called LLM worker.js. The full code can be found and examined in the GitHub repository. Web LLM is used when Web GPU is available, while Transformers.js is used when Web GPU is not available. While Transformers.js can also take advantage of Web GPU, Web LLM was chosen because it uses the MLC structure, which allows for loading models larger than 2 GB. For users with larger GPUs, this allows for much larger models, such as 8B models, to be loaded into the browser. Since Web LLM requires a GPU, Transformers.js provides the fallback for CPU-only users. If there is a strong FAQ response, it always takes precedent and is used for Bob's response. If there are text files to pull from and no LLM is loaded, the response is simply the best paragraph context match. If there is an LLM loaded, the text information is fed to the LLM in order to generate the best answer. The overall framework allows for modifications or customizations based on the end need. User hardware can also play a role, as having the embedding model, TTS model, and an LLM all loaded can still be quite taxing on the user system. The machine I primarily run on can easily handle all models with its 12 GB NVIDIA RTX 3060 GPU. However, the 4 GB P2000 GPU laptop used to create this content struggles to have all three loaded without much longer response times or potential crashes. While I am created to show what can be done locally and to share some tips and tricks to perfect the process of using LLMs, a web production system would still benefit from server-housed models, even small ones like those used here, to avoid issues arising from user hardware limitations. However, since my interface allows for the selection of which models are running and different size options for the LLM, I still provide a great playground for the tinkerer, or in an environment with users who are somewhat knowledgeable about what their system can handle. I hope to see you around.